Welcome back. And so we are, new guest arrived, very important guest. And one of them now will talk about more details, will give more details about the background functionalities of the layer system. At least, give some clues about the thoughts behind this functional approach to the background.
But sorry to interrupt, is that the right moment really? Because this sounds like we're going into one hole very deep instead of staying on the just.
It was just to complete the picture of the layer X, but it's also up to you. Will you prefer, guys, to stay on top and then go deeper later, or just complete the topics and I don't know. You would prefer to go.
I would prefer to get the bigger picture before we dive into the details, no? What?
Few words maybe about the background.
I wanted to
Yes,
Sebastian.
Yeah,
I didn't want to make a long story because I didn't prepare one. So no. At one point when Kairos was developed, we just had this idea that it would be very nice if something like a timeline could be transparent, or a track could be transparent, or I know you're stuck with other terminology, but in the end we want to use all these nodes now for building a timeline, for example. So the idea was to be able to create a track that's transparent, and the question was, can we just somehow take the value and merge it somehow with the alpha value and output some value downstream that then gets processed further on? And we figured out now, no, it's not possible. We have to treat value and alpha separately. Yeah. Why is that? It's very easy. Yeah. If you blend something, a transparent object onto a background, you need to have a opaque background. If you think about 3D engines, transparent objects always get drawn from the back to the front, because the idea is you need some background, then you can draw something transparent on top. Then again, so you have to sort the objects from back to front in order to get the correct result. Yeah. So that's why we then figured out that we need somehow a background in order to be able to implement this. If you have, let's say you have a timeline up there with transparent tracks, and you want to use this timeline in several downstream scenarios, like here and there, and there's a different background than there. You just want to use this transparent track in different cases. So so the idea then was to somehow feed the opaque background upstream, so that we can correctly blend the transparent track on top. So this is the reason why there's somewhere here, I don't know exactly, there's something background, background function. Background function actually is already performance optimization. It would be also an idea to just feed a value here, like in this case, float. You could feed it here, and upstream you could get it back somehow and use it and blend on top and then give back the result. Background function is just the idea that not always you need the background. If upstream you have an opaque track, you don't need to know all what led to the background. You don't have to compute the background. You can just compute the value and that's your result. But if you have actually you're in a situation where you are in a transparent part of your track, then you need to sample the background, and this is why we have a background function input pin here to feed that background. That's it.
That's it. Thank you. Okay, so I think we can start finally to talk about Kairos. So if we go back here, as we say, Kairos system is made of these 3 libraries. We had a look at the first 2, Alchemix, Layer X, we understood where they are. So let's think about it now. What's missing? What's the goal that we want to have? Because that's the key element. Let's start from there. What we want to do? We have nice patches, we have systems. In the end, at a very high level, we want to take control over this system, which generally are parametric systems. Like, there are some classes or modules with properties. Each one of them summarizes a parameter. As a name is identifiable and has a value. So the ultimate goal is to take control over systems. And that's something that really none of these 2 libraries really care about. And they just Alchemix just manipulate pure values, doesn't care about anything else. Layer X introduces this notion of the layer and the fact that you can compose layers on top of each other. They introduce space, but still, if we look at this patch here, what I see here is a beautiful graph, okay, that from this set of nodes and functionality and this set of possible states, okay, of my value, in the end, all these nodes compute me one final output, right? Okay, so if we take this and think in perspective, let's say we have a system, an application that we want to take control over. That's a series of parameters, right? And potentially we might say, okay, this is a very cool set of tools that I can generate value with in different ways, with compositors, timelines, interpolators. But ideally, I would like to do such a thing, right? Synthesize these values for each one of the parameters of my system. No, that's how I design like a scene in my live show. It's a preset. It's just a collection of, okay, for this parameter, this will be the value, which potentially could be a graph like this, huh? Why not? For this other parameter, it's a constant that I type in. For this other parameter, it's another graph, maybe different from here, no? Right? So potentially, when we are talking about system at the systematic level, each one of the parameters is potentially a graph of this kind, right? And that's what Kairos does. It's a set of higher level nodes, like a timeline, like a compositor, that internally manage collections of parameters, right? And dynamically, internally, they build graphs like this for each one of these parameters, right? Yeah, and that's the key element. Let me check what's on the list here. I don't know what's written there. I didn't. Okay, so what are the implications of this? So this already introduced different aspects to the problem. First, how to dynamically generate these graphs of layers that in the end synthesize all the values for our system. This is one topic. Another topic is data binding. So how I basically map those graphs that are generated in the output of those graphs to my system. How I link to properties into my system. This is another topic, completely independent. And you could have another topic, which is, okay, how I expose these outputs to network. No, that's another kind of binding to, yeah. Still, these are separate topics. So first, we should say, how can we have this Kairos system where when I can introduce the notion of parameters, because a parameter is not anymore just a number, just a value. It's a value which has a meaning in a specific context. So this value here is parameter 1 in my system. So I need to treat it in a meaningful way, because that represents something. I need to to relate to the way I will use it in the system, so that when I timeline that value, I'm timelining parameter 1, okay, and that will end up writing into my parameter 1 property. Or let's say that I wanna blend on top 2 timelines, blend on top of each other 2 timelines, and in each one of them I have a parameter 1 track. Somehow the Kairos system has to figure out that, okay, those are tracks, but they represent the same parameter. So I need to make them relating to each other at that level. Otherwise, it wouldn't be meaningful to work with them and to combine them. So, and that's what Kairos does. It's creating this level of abstraction where these layers suddenly have meanings. They represent something, and Kairos does that, introducing the idea of a track. A track is the association between a parameter and a layer. So suddenly, this is not just a layer; it has like an identity. Okay. So when I pass it to some other complex systems that deals with tracks, they can say, okay, I also have a track with that represents that parameter. Maybe it's probably meaningful if I align them and I treat them as part of the same output. So they need to align. That's what happened. I thought, okay. This is an example, right? So we have a timeline A and B. This is parameter 1, 2 tracks each, parameter 1 and parameter 2, parameter 1 and parameter 3. Let's say that I nest these 2 timelines into this compositor with 2 clips, right? So this clip basically represents this timeline, and this one represents this other one. Okay. This is just a very high level representation of that. Under the hood, what needs to happen into this complex object, Kairos tool, is that each one of them carries some tracks, right? With certain identities. So if I need to rename this. So if I internally look at the tracks, what happens there
that each one of them carries these tracks. So what they need to do is correlating them to each other. Like let's go to parameter 1 view. This clip carries this parameter 1, so we have it, and also this timeline here has parameter 1, so we have a clip there. But let's say parameter 2 is it's present only in the time. Yeah, it's this typo. Yeah, it's present only in this timeline here. So at the very bottom level, there's really nothing there that I need to relate to. And imagine that what we are looking here at is the compositor 1D layer of layer X. So what happens? So this is the Kairos compositor is a higher view, but underneath, for each of the tracks that are handled, there is a compositor 1D happening there. So yeah, so for each of the tracks, you got a compositor 1D, which we saw not here, was the other patch, and it gets configured with the proper inputs, the proper clips. So in the end, the Kairos compositor is just a collection of compositors 1D, right? That each one operating on one track, combining the tracks that comes from upstream. So you can imagine, like, what happens there is that for each of the track, one graph like this get created, huh? And this is what happens here. Is patched because I created this node set in the library so that you can use it as nodes. But in Kairos, this happens dynamically under the hood. So you don't patch anything there. All these instances, keyframe shapes and layers get created on the fly because it's a runtime thing, no? You can have a compositor where you connect a timeline and suddenly you need to change the graph internally because you add some new, you extend the graph, no? With this other tool in some of the plots, if they are matching from upstream. So this is Kairos. This is the system that allows to, in real time, like in runtime, create graphs of layers, handle them, aligning them, the parameters, so that they make sense together and you can get something meaningful at the end. So yeah, I expect some questions now. First round.
What I see is now on all of the 3 levels, alchemy, layer, and Kairos, we have the term composition compositor introduced. Huh? Is that on purpose, or is it just for the lack of better specific names? Because it's hard to talk about it already, having the same term on 3 different levels. Would it make sense to try to think about introducing different names, or is it just fine because?
I mean, I would say that the final user is not even in touch with what's under the hood, right?
Yeah.
Doesn't even see what the node from Alchemix compose does. It doesn't even, never see.
Yeah, of course. There is some people who just see the surface.
Just like the composer, a high level tool, and they're just exposed to that. That's one aspect. Yeah, I mean, we could find other terminologies. Didn't spend much time, but also the Kairos compositor just does that, takes clips and allows you to compose them on top of each other. And this clip can represent other tools like timelines or composer or whatever. But in the end, it's like an extension of the inner functionality, which is the compositor 1D that operates with layers, extended at a systematic level, so that you can abstract over. You don't need to manually create all these graphs for each of the categories you want to operate on. You just want to use the principle behind the compositor at this systematic level, so very high level, where you just want to deal with collection of parameters. So that was it. And, I understand it.
For the first time,
It can be confusing.
Like, having the same term all over the place,
I know.
like hard to distinguish them. What are we
I know.
That's,
This is up to discussion, and we can figure out. But so, is it clear somehow what's happened, what needs to happen? So let me check. I don't remember if I am. I can open the nugget here. No.
so say it again with one word. What's the tagline of what Kairos part does? One sentence, like what's the gist of it?
Still don't have that sense.
It offers you a basically different instruments to think in and to build these graphs. You can build all these graphs manually with the node set you have at hand. But you would think in this data flow way. And Kairos is trying to basically give you different editors, let's say.
I think it takes the layer X functionalities and apply them to a higher level of abstraction, which is a systematic view. So you don't want to, you want to apply the same concept, like interpolating, compositing, not to one value, but to one parameter. And how this, what are the implications of this into a complex graph? Because you have parameters suddenly. You're not just, you don't have layers, right? You have parameters that can relate to some of other parameters in other parts of the graph. So you are on a higher level where suddenly you have more information of this graph, and then you need to treat accordingly. But the idea is really to take the powerful concepts of layer X and be able to, in a flexible way, because that's the whole point. You could patch your entire control system with all the preset systems of your application just with Node, as we did, right?
Yeah.
We don't want to do it. It would be such a massive work if you think about it. For each parameter, you need to patch a graph like that, even though maybe some of them are exactly the same because you want to control a collection of parameters like in a preset with one idea, which is one clip. So you will need to copy these patches all over the place and then adjust this in the same way to match this idea of having one control clip that represents a bunch of parameters. No? So it doesn't make sense to patch those things because you are suddenly working on a higher level of abstraction, and you want to read. This would be too complex to handle. If you want to go higher, you need to simplify the problem, right? And say, okay, I want to just see what they represent, these values. So, and just by dragging around and organizing concepts, I can automatically make sure that the machinery down there builds those graphs that reflect my intention above. I just want to work with ideas at that level.
But so the.
This wasn't a sentence.
Work on the compressed element, but, is it so that? Because that's, I understood, but layer X, the cool thing is you can just patch it. It's a lot of work, but you can just patch it. No additional things needed, no? And so is it so that when you talk about the Kairos part, that requires a new UI?
Yes.
That without UI,
Yes.
Kairos is nothing. Like
Yeah.
Kairos is the UI. then.
This level of abstraction is not something that you can represent into BL patches.
Yeah.
Because why? Because it's a dynamic, living thing. So, and you need to generate dynamic graphs out of it. So you will need to generate patches if you want. I don't know.
But in what sense dynamic? Like when would be a graph like this built? Not when I move the timeline or anything, no? So
No.
so what would be the moment?
No,
that-
while you edit, I mean, like let's say you create a compositor and in a clip you suddenly
Yeah,
connect a timeline. Suddenly these graphs needs to connect and relate and extend them. No, that's the dynamics
Yeah.
of the machinery, and that's like what corresponds to patching those
Yeah.
graphs
Yeah.
again,
Yeah.
or connecting those graphs into a unit one. So
the Kairos is a UI on top of layer X. To make layer X
I wouldn't say so because
usable.
layer
for
X
UI.
doesn't have any doesn't bother about any idea of
Exactly.
what the values are.
Uh-huh.
And I think that's the essence of this.
Mhm.
Why do we need to dynamically create these graphs? Because we have ideas about what these graphs mean. So is idea driven the way these graphs get built and handled. So I think Kairos introduced this level in which you add the meaning to these graphs.
Mhm.
And by adding that, that defines how they relate to each other.
But by patching the thing, you could also add meaning, no? It's a lot of work, but if you patch your layer X graphs for all of your parameters, you add that meaning.
Yeah, you can do everything, like just with plus and multiply, but there is nothing in your patch that is meant to represent the parameter, no? So Kairos state this, okay, this now is an object, as an identity, and he's like it's a track which represents a parameter and connects to a layer, represents it, like switching to object orientation, no? Suddenly you give a meaning to things. Of course, you could patch everything, like
So if
Right.
that is track a data type
yes.
of the Kairos library introduces.
So I started to do something like we imagine like a timeline suddenly. What shall I say? First of all, are there questions? Meaning, help me.
Yeah, not a question, but another try to separate the libraries. Like I would say one goal of Kairos is to be able to build a timeline, which is a tool, which is not programming. It's not about programming, it's about playing with data and putting in it in some context and yeah, for your project, like playing with data. And there are other tools like the compositor or maybe more of those editors where you can play with data and yeah. So that's the most obvious difference between layer X and
Yeah.
Kairos. That the one thing is a tool, the other thing is a library. That okay, and then Kairos is everything, and then there are small parts that could that you can think of themselves as a set of libraries that got extracted so that you can make use of them without the whole system. So the better question would be like what's not Kairos, and that's Alchemy X and that's Layer X, and all the rest is Kairos. And then why is it why is it UI and plus the parameters and making them align, and why is Kairos all covering all this? And there, I think this is your next slide where you will go to. Kairos is not only about this one timeline where you have data, and then you can sample the timeline, and you have those constant keyframes. And it's not only about feeding live data to your keyframes, what you will explain later, but it's even more, it's connecting the different timelines or different compositions, you know, that it's so, and for that, the parameters need to be in there. So there's a mechanism to make them align.
Yeah.
So you have a portal in your clip so that you can go from one timeline to the other, and you go in there, and then you can sample another timeline, and to make that work, to be able to connect those bigger blocks, you need to have some sort of, you know, glue, and the glue is are these parameters. No, you have to make them make the tracks identifiable. No?
Yeah, of course.
Is it the
a good
term
point, like,
track and parameter? Are they the same, or?
no. Track is what basically binds somehow a layer and with a parameter. Parameter is like the idea of what this track is meant to be, no? Like that potentially corresponds to a parameter in my system. So it allows me to identify really, like to label with a certain identity my layer. And this is, yeah, that's the key point. In the moment you want to blend together two timelines, what should happen? Each one of them is a collection. Under the hood is a collection of layers. Okay, I have two collection of layers. How should I relate them somehow if they are just layers?
No, but what you could do is you could have a timeline with tracks, and then you sample the timeline, sample the different tracks, you get values back. Use some of those values and feed them here and there, and maybe you feed them to the dynamic keyframe of one other timeline. You know, you could do that, but it's then not really. It's very much manual work, and often you don't need that. You don't want to make every parameter behave differently. You want to have a big idea, like these are my compositions. Here I want a timeline stuff. Here I want to place stuff in a 2D editor. I don't know, and sample the data differently. And often enough, these big ideas are always the same, and you just want to make this work, this connection work for all the parameters.
I only noticed now that I think what's confusing is that the first thing we talk about is not the simplest use case, but we are already merging timelines. Can we just talk about one timeline with two tracks, and how does that look? And not like the first example is
So-
already merging timeline.
Yeah, I wanted to say the same.
I only noticed now, look, the
Okay, you have a timeline.
There's also sophisticated
Okay.
nesting case already, while you did not.
You have a timeline, okay. You could have a timeline there. If you're just interested in outputting pins, like in the good old timeline in beta, you don't give a shit about where are those tracks. It's up to you as a patcher to take those output pins and connect to something that for you makes sense. But you could connect everywhere. It's
Exactly.
compatible, no?
Exactly. So
So you are adding the meaning to that just value, it's nothing, by mapping into certain aspects of your system. You are parameterizing it somehow, you're giving it a meaning, okay? So, but internally, you could have just two sampler there. Each one is as a pure function that samples and returns a value there.
So maybe Kairos is first, it's not this parameter thing, but it's the tool character that you can dynamically add tracks in one timeline, and you can just easily specify which data type, and you just can play. Main point of Kairos, I think, is to offer a tool or several tools, and then you can just play. And then some
because
additional.
such a simple timeline like the one that I just described, you don't need Kairos for that. No? That's something that you can do with layer X.
But layer X doesn't have a
It's
UI.
not even layer X. You can do it, yeah, maybe with layer X because it comes with some functionality already. You could just, each one of them could be an interpolated 1D, as we did, right? Where you put clips, and the output, each of the pins is just something that samples. That's it. You don't need Kairos.
So you could build a very trivial UI.
already
on top
with
of
layer
layer
X.
X, so.
Yeah, that was my question as well. So you're going to build the UI on top of Kairos, why you just don't make the UI on top of the layer X as well?
This is another topic.
Yeah,
It's so modular now, the system, that it probably makes sense to think, okay, let's make a UI for an interpolator 1D, which in the end is exactly what gets used into this other UI, add something around, so in this modular way. But wait, just a second. What's the step that really shows the limit of my tool here? Let's say that, okay, if I have just two tracks with two output pins and I connect them to my other models. That's it. I'm adding the meaning just by connecting those. What if I have hundreds of parameters in my system and I don't want to connect manually things around? It would be too much. I just want to say, I have a track and I know that this track is my particle velocity in my system. And then I will have some functionality that knows, okay, that's my force velocity, force particle velocity value parameter, and I will find my way to connect it into my system. If suddenly you need to, not just you in your head, make a meaning of things connecting, you need to add this, to put this meaning making machinery into the code, because the computer needs to know, okay, where should I connect this track output to, right? Suddenly, things have meaning. So the computer needs to know, okay, where I should route, to what I should bind this value.
So here, the first time you used the word binding, isn't that a super essential thing then in the whole?
Well, it depends. It depends. Yeah, of course.
Not necessarily.
Well, Kairos stands by itself also. Still, naming parameters allows you to easily build complex graphs. Even still, if at the end you just want to have, I don't know, 3 outputs, why not? You can just have 4 output pins, but still the graphs that get built dynamically are very complex and vast. Still, my example that I made is just to say that whenever you want to use this abstraction that you're using, this meaning that you're adding on top of the data to correlate a system to another one, to bind Kairos system to your own system that you want to control, inevitably you need to put this meaning into the code. So the Kairos binder, just what it does is simply get all the tracks, check what kind of parameters they are, and then literally using reflection, it takes this address, this path of the parameter, and writes that value into a complex data type. So at that level, if you want to have this kind of flexibility, you need to have the idea of what is this parameter. Otherwise, you couldn't track it in a system.
And is that something that we can already look at in a patch, or is that not existing yet?
No, but that's I mean, the old Kairos is already doing that. So
But for the new.
for the new one, I can show you. Yes. So let me just close this as. So, yeah, okay. Just to show you the current state of things.
Wow. But you could also, couldn't you just simply open the channels help patch? It's doing exactly that in the end, or not?
Which one?
If that's the question, that you basically address something in a data structure and write there, just with a path, and that was the question, to show that as a patch.
That's the binding aspect.
I mean, the channel things we moved from Ingui to call it should do that, no? The binding, this is already this binding concept. I just I don't know.
Yeah, I don't know.
The question was about whether you can control something in a, oh, no?
Yeah,
Anywhere?
I'm still trying to get closer with my understanding of what things are. So anything. It sounded now like this binding idea, this automatic binding, instead of you connecting things. This is kind of a core.
It's an essential part.
Yes.
As soon as you get out of Kairos, it's an essential part to take whatever Kairos system is doing and correlating it. I mean, connecting to something else in a meaningful way. Then obviously it's like the bridge, the essential bridge. No? Binding mechanism. So let me check.
Even more essential than merging timelines. What's the most, primitive thing that shows us?
No, where is it?
Manage nuggets. Nuggets.
Like that.
Yeah, he's basically building all of his libraries.
Very experienced user.
Not even git clone. I would call it git. No, it's git init. That's what it knows. And git push.
Let's see if it works with this version.
It's all broken everything.
I did this a few months ago. Let's forget about that. We have something.
But there's a data binding patch where you create a record and write back to it.
No. There is another one that we can try to open, which is Where is the fine? Position 3. This would be a mess, I'm pretty sure. No, really. I wanted to check. Well, we can have a look at this.
So we're looking at the old version now because that part of the concept hasn't changed.
Yeah,
Yeah,
this is
that's
something. Say, so this is, I mean, terminologies have been changed, but still they are there. We have a compositor, which is this tool here. It's 1D. We can sample using one dimension. And we have two clips. This is somehow exactly the example that I put here, right? We have two timelines and a compositor, right? This is the case. A compositor, two timelines, right? And these are the two clips. This is one timeline, this is the other one. So if I select this one, what's in there? There's my value, parameter 1, color parameter 2. So, and there are two tracks, right? And they have some values. This is, I guess, a constant value. This is a live input value that comes from here. And this is a function, I think, yeah, because I'm using the sampling position to do a simplex, as the example that we did at the beginning. No? I'm just using the sample position to generate a value. And that's it. So if we look at the output, just doing what expected, no? Just interpolate to one, the other as well, and it goes. Okay, then let's check this other one here. Sorry, this one. As again, under two channels, two tracks that they are the same parameter of this other one, right? So, but obviously in these tracks there are other things like this constant clip, one value there. And there's this my composition clip, which accepts another compositor that takes another two timelines, whatever. It's a complex thing. It gets nested here. Let's just forget about this. But anyway, the core element, the key thing here is that these two timelines has the same channels, the same tracks there with the same parameters. So my compositor down here, yeah, it's nice to see, and this is why it's playful, because I can just play around with these two objects, saying, I want to have my timeline here and my timeline here, and I want to compose them on top of each other. Yeah, that's easy. And that's the whole point of having such a high level tool, no? But under the hood, what should happen? This object here, this tool under the hood, it deals with single tracks, not single parameters. So it aligns them, no, in a way that it can build these different inner compositors that really takes care of composing layers that maybe comes from two different timelines, but still they can be manipulated in the same compositor. So in the end, thanks to that, you can say, okay, I want to have here I will have my clip, which somehow map to this timeline here, you see. As soon as I get there, suddenly I start to, because there's an alpha in and out, I start to get to the values that come from here, because this is on top. If I move this on top of it, suddenly this will have, it's opaque because there is no transparency there, so it will just be the actual output, right? But as you see, this is a very high level representation, because inside here, there are many tracks flowing through. So this machinery here takes care of checking what tracks are in this upper timeline, what tracks are in the other one, is there something that they are, do they have the same tracks in some parts? So I need to align those so that I can compose what they contain in a meaningful way, and so on. That's why as soon as this is what happens under the hood.
This is the only time where you actually see the layers, no? The layer aspect. The background is at the bottom. And then these little bars are the layers that are on top of each other, right?
This representation, clearly showed, because what does it represent is also an ordering in which these layers get sorted, so that when they get computed, they reflect that order. And here we have a tool that represents that order. So even though if I move this up, internally, there are many channels that get pulled, so each one of these will jump there, right? Because it's like, okay, I'm moving this, which represents all these tracks. So in each track compositor, I will have a clip that represents the upper track, and it will move accordingly. Both will move there. So it's just a way from a very simple object to manipulate a very complex set of tracks down there. And okay. And for example, when I'm here, and let's see if it works. So you see these are simple tracks, but there is also this composition track here where I can add composition clips. If I add a composition clip, I have a new pin here, right? Oh, did I break it? No. I have a new composition clip, and I can connect a composition, which is another Kairos tool. It can be a timeline, can be a compositor, can be so if I connect this other timeline, suddenly I have a clip which sample this other timeline there, right? But what happens? This complex clip here, what it does, it check what do you connect here? Okay, it's a composition which has these two tracks. Do I have tracks here which have the same name, they represent the same parameter? If yes, then I will insert like a proxy clip here, so that I can relate what's coming from that composition to what I have here, because I know that the parameter one that is present there in that composition is the same parameter of this one. So they should really relate to each other.
Otherwise, it would create a new track.
Yes, but it wouldn't make sense at that point, no? Because I still want to operate on parameter one.
Yeah, but if you have parameter 3 in this composition,
If I, like, for example, let's go here, or should we have another one here? Let's see, I don't know why it's red, but still, let's just attach to that. Here we attach to this. Let's see. It's sort of miracle what's happening here now. It still doesn't break. So if I add that's one thing. This is a prototype, you know, this UI is not meant to be like a, let's say we add a new parameter here. What matters is the path 2, 3, whatever. Oh, something, okay, no. And it's it's a flow, it's just a simple flow. If I create, but I want to see here, if we create it, suddenly it appears also here. Why? Because this clip here is listening to this other composition, and here there was a track insert, a new track, right, with this new parameter, which is not present here. So it needs to, since we want to collect all these channels, these tracks till the very bottom, it needs to introduce it, no? So it can still be like sampled together with the others and so on. And then I can also add maybe a clip here at this level. And suddenly I'm operating at this level, defining a state of this parameter, which will relate to what comes from there. No?
Why does this clip doesn't show up on the topmost one?
Well, because this is just a window.
Oh yeah,
Just a window over up there.
Yeah, but
but-
they have the same idea and everything. So.
Yeah,
Yeah. Okay. Yeah. No,
but
okay, get it.
because they are the same parameters, so that it's
just
obvious that I
controlled
need
from
to.
different places.
And as soon as if I remove it here, delete. Well, now because I edited, yeah, that's why
Oh,
it
okay.
stayed. But you can see like that. So whatever, what's happening? RGB. Okay, if I remove it from here, also that will go away.
Okay.
Because this track here was just introduced by this other composition here, up here. You see, but this allows you to take whatever composition is there, like a timeline with set of tracks, and inject it in a meaningful way into this other context, and align these parameters, these tracks, in a meaningful way, so that you can really use the functionality of this thing, which is interpolating between values. I want to interpolate this value of my parameter with the value of that parameter that comes from there when I sample that timeline. So I should be able to place it here into this context. And that's what happens automatically as soon as I connect, no? If, like, again, if I type something, whatever, create another track, if I disconnect here, suddenly there's no track there anymore, because the other track, the third track, was just introduced from here, right? As soon as I connect, I will have that other one there, because it gets introduced. So at the very bottom of this graph, I will have all the tracks that I can sample.
And maybe it's like, maybe we should discuss that later, but how do the playheads behave?
Details.
No, I mean, like, if you play there, does it play there as well? If you scrub there, does it scrub there as well? Okay. So it's the same clock. No.
Yes, this is thanks to the fact that, yeah,
but
the old,
later.
yeah. There's a Kairos timer, so to say. It's just a clock that gets propagated upstream, considering the offset. Also, because if you're at this level, when you're here, when you sample you should basically get the offset in the other one up there, because it's like starting from the beginning of the clip.
Yeah.
So, yeah, there's, I don't know what is following now. Yeah. Okay. So, is it clear now that you need this knowledge, this concept of the parameter, in order to align these graphs and to make meaning with it, to build these graphs? You need to have the notion of what they represent, these branches and this. So, and that's the key. In fact, track is really just about attaching this meaning to a layer. It's just that. And just this notion allows Kairos to say, yeah, this is not just a layer that I can relate to any layer that I have here. I see this is that parameter, and I know that there is another layer that which is that parameter is represent that parameter. So that's what I need to relate to. Because in the end, it's about making sense of collections of tracks, right? If I have a timeline there with a collection of tracks, another timeline here with a collection of tracks, if they are just tracks, what should I do? Shall I just interpolate between the first track and the second track, the first track and the
I have a question of
Yeah.
that. What happens, I mean, basically, it's about, we introduce names and we correlate things by name. Right?
Yeah. Hmm. But yeah, parameter.
But what happens if I change the name?
Uh,
Let's say, it's nice, but it also comes with these issues, right? But they need to be addressed at some point.
Yeah, but that, I mean.
Let's say you change the name from the acceleration, we had a typo there, and you wrote acceleration with 1C, and then you know. And then you change it
Yeah.
somewhere, want to fix it, commit it, and it's all broken because you.
It's not broken, it's just a different graph suddenly.
Yeah, but
Because
your system is broken, it doesn't behave like it should.
Of course, but also, I mean, that's why this is, we did it manually here. But Kairos, already in the old nugget, comes with like the binder, the Kairos binder that was there. It was allowed you to connect a data type to a Kairos graph. But not only that, it was taking care of traversing the data type and also exposing it. We had all those parameters that you might want to control. No? And there is this rack mode in the Kairos tools where you don't need to manually add channels with a proper path so that you know that it will go through the entire thing pointing to that property. In an ideal world, what do you want to do? Okay, I'm controlling that system. Right click or new track. What's available there? These are the parameters that I want to control. And that's it. But that's just cosmetics, no? That you add on top to utilities. That okay, it's an easy. You don't need to manually choose the parameters. You can have a list of exposed parameters, available parameters, and you can link to them. And then it's also a choice. Whenever, if you want to change this parameter, what you're doing, first of all, I would say.
What I'm trying to say was a little bit that the source of truth, let's put it that way, like this let's say this acceleration you have, or the gravity, right? The gravity in your simulation. And of course you have one gravity. But this you probably define somewhere. And you don't. What I'm trying to say is a parameter refers to that one thing, to that one gravity, to the gravity of the Earth, and not that you have to define it when I have it basically showing up at 3 different other places in 3 other editors, let's say. That not they introduce that Earth gravity again and again and again. That's kind of the distinction between the parameter and the track, you could say maybe, that one refers to something. Yeah, which is you wouldn't unique to your whole thing, and the other is just a local, maybe a local.
Yeah, you shouldn't think of the parameter as a absolute thing. Okay, that exactly represent that instantiation of something in my system. It's literally like a label. It's like a tag. You tag. Imagine it's just like a tag on a label. So as soon as it matches with something else into your system, they will relate with each other. Then it's up to you, okay, that tag also outside Kairos has the meaning that yes, that corresponds to a parameter in my system. No?
Yeah.
So it's just about tagging.
It's just here, for example, here we have name and little, and my value is parent one. So this is already in my head, it's like exploding already there immediately because I don't know anymore. Is that important or not? It's one referring to, you know what I mean?
Forget about it. Imagine that there is just the channel, just the address. What really matters is the tag, right? So whenever you have okay, this is a
So maybe we could in the long term get rid of one of those.
Yeah.
Okay.
Yeah. This is, let's say, this is what really matters. What really gets used to align things is the path. In this, this is the path. It's called path because it's like already thinking to data type and okay, point to a unique specific property, you know. So that's a unique identified ID. And the name is just a name that you can give to that thing. But in the end, think about, okay, there's one key here, just a key, one thing there that gets used to align things.
Can get used.
I mean, as soon as you connect
Yeah.
these things into a unique graph, they are part of the same graph, then they will get used to make meaning across the entire graph.
That totally makes sense that there's not a way for the system to.
Otherwise,
If I don't have links to connect stuff, then it needs to go by name. Yeah.
yeah, otherwise it will go by order of tracks, which totally doesn't make any sense. So that's it.
But I think at one point you could also say, like in general now, is that these downstream nodes, they always basically go to the leaves of the system, right? So even though it's a composed thing, even though it's a composition and nesting of many, in the end, the general idea here, or the core idea is that a consumer downstream, like this compositor, is traversing through all the leaves and basically putting them together. So it's not like this, I'm nesting into nesting into nesting, so it's more or less like this.
Well, each of these,
Going deep first,
each one,
grabbing the parameters.
each of these tools takes care of aligning these sources and providing in the end a list of tracks.
Yes.
And then again, it will be just a task of another one there to take, okay, in fact, the interface of a composition, which is those Kairos tools, the main thing that you can ask is get channel, get tracks, because in the end, the compositor down here will need to, okay, give me your tracks and give me your tracks. That's the first thing. Okay, I have these tracks, which mean this parameter, so I need to align them in that way and build the graph accordingly. And each one of them does that, eventually introducing some tracks which are, so in the end you have the complete collection of tracks that are used, and then that's what you pass over as yourself as a composition, and so on. Each one of these tools make sure to somehow take care of the graph and the alignment of the tracks in the graph.
Yeah, so we could rephrase and say we have the layer, and then on top we have the parameter, which basically gives the layer an address for other tools to align multiple layers and compose them into new ones, which again they could sell as a different name or not.
Yeah.
Back to the question, what was Kairos, I think.
Yeah.
You said the combination of a parameter and a layer
Makes a track.
makes a track,
Yeah, track.
and we can see the tracks. So that's a very easy explanation, and it's just the parameters can be used for this auto alignment, but they're maybe also useful for even if you just have one timeline, it's just.
And you can notice here that in the timeline tool, you can see the tracks. In the compositor, you don't see them. Because this is a even more higher view. Like you want to represent here, not the tracks, but the compositions.
The
Right.
entire scene, right?
Yes. But under the hood, and this is something that I always dream of implementing, like another mode of this tool, where it shows you what happens under the hood. These are the tracks, and for each one of them, there are these clips. No, it would make sense to see that as well.
Okay, so I wanted to ask this question like 15 minutes ago, as Sebastian also mentioned. So we have this. So what you have here on the top, this is you attach it to the compositor. This is still a layer.
No. This is the compositor.
This is the compositor, but then inside the compositor, as we saw earlier in the newer version, that you have clips, or you have basically this manifestation of data that there's either there are clips or keyframes, right? So when you go inside each of these compositors, you see those clips, right? You just saw clips. You just saw inside each of them there's a clip, right?
Wait.
Now
The thing is that each one of these carries a collection of tracks, right? So what needs to happen is exactly what I sketched here, no? Each one of these represents a list of tracks.
Yeah.
So,
one
under the
part
hood-
missing- before going further, the part I'm missing is that coming from creating, we have a layer. And then if you remember in the morning, we had a layer, and then the layer, we could say, okay, shape it like either as a clip or a keyframe, and then you give it to the compositor, for example, right?
Yes,
And
this
then
is,
that compositor.
this is what we were looking at.
Yeah, good.
Yes.
Yeah.
So at the very bottom, okay, when we are just looking at the track view, again, sorry, just my name error.
So here we don't-
This is the object that we were looking at this
Yeah,
morning. This
yeah,
compositor, where we had like a shape, which is a clip,
yeah,
which is this one, which holds a value, huh? It's
Yeah.
a layer itself that points to something in this other timeline.
yeah,
Okay, but this itself is a layer. No, is the compositor 1D that we saw this morning. Is a layer that I can sample.
yeah. And then when do
And
you
this-
introduce track?
Huh?
When do you introduce a track?
Because this is not just a compositor 1D, is the compositor 1D that will produce a value for the parameter 1 when I sampled it. And that's why, oh, that's already, yeah. And that's why under the hood, you don't see, you just wanna, okay, compose this collection of tracks with this one. But under the hood, you are building 3 different graphs of layers, 1 per track.
You just put that side by side with the
With a patch.
Yeah,
with the composition window.
yeah, exactly. Yeah,
Because
So this one is this, right?
Yeah,
These 2.
yeah.
and then, I mean, in theory, you could
Switch to a mode.
you could have a UI that shows
These 3,
that shows like
like here,
3
like here, you mean?
3 tracks in here and 3 tracks in here, or the other way around. You have something like this representation,
Yeah,
3 tracks,
Yeah.
and inside you see this the layers on top of each other. No, in the one track you have this. In the next track you just have 1 layer, and in the third track you have again 2 layers.
so,
In theory.
yeah, in theory, I mean,
You could visualize it in different ways. You could visualize different aspects of
this
it.
clip,
You could switch between one or other aspect, but it's both there, no? You have the layers
is there.
per track.
Yeah.
Yeah.
I mean, you could literally paste the timeline UI here, right? Because that's what this clip represents an entire timeline with several tracks. So you could put it there. It would make sense. Then you would have a timeline here with several tracks, a timeline here with several tracks, and you know that this track, which has this parameter, needs to relate to that track in the other timeline. So under the hood, for each of the track, I will need to build a graph, as we know, and which contains the clips, one from one timeline, one from the other timeline, so that I can blend those layers together. Wow. Are there questions also from network? Everyone is just overwhelmed,
No,
like me.
no questions so far.
All clear. No, they just gave up.
No, I guess, where do we start?
No, but to be honest, I think I'm a bit confused with the terminologies, like when, which is something that I need to see them, I need to play around with. But beside that, I think it's quite confusing.
I think Kairos is clearer for me than the Greek and lyrics. It's clearer, Kairos for me than the what's under the hood with lyrics and
This part is clear for you.
clearer, yeah.
Okay. At least for one person.
The new Kairos is it's just the GitHub at the moment.
Can you say what?
Is only the GitHub, there's a GitHub link only, not the Nugget.
Nugget is still the old version.
But the GitHub is the new one.
Yeah, there is a development
I
branch there.
11 days ago. Like,
Yeah, because I'm in a temporary stay. I'm working in another.
See you tomorrow.
Right?
10 o'clock, sir.
Yes.
Then you can give me the gist.
It will be a stand-up tomorrow morning.
Ciao.
Ciao.
There's no air here.
Oh no, but it's a bit noisy maybe.
what you do?
Well, I know, I was saying, yeah, I started this other repository, Structure X, because I wanted to separate another part of Kairos, but then I give up, but I continue to develop there. So the new Kairos is in there, and I can show you, oh, no, still there's a lot that we can have a look at. So, because, yeah, it's important that you, there's still can grasp a lot. So I can show you Kairos, what it is. So when, okay. This is the current state of Kairos. Track, we say, no, that track is an essential element of Kairos. So, and even very important is the parameter, how to identify a parameter and make a track. No, that is combination of parameter and a value source, let's say. Parameter is, yeah, it's just path, name, still, this is something we can change, whatever. Type full name, because we say, okay, this parameter has this type, so is a float or is a color, it's something concrete. It has also attributes. Potentially we can add attributes to it, just to enrich the knowledge about this parameter. And then the track, hello, as you, yeah, there are some helper interfaces we'll see later, but mainly you can well, this is just coming from the old, not essential, but the main thing is that you can ask for the parameter. Okay, I got a track, and give me your parameter. I want to see who you are, basically. And yeah, and then there was the model, no? And then the track, the main thing that you can ask in the runtime to a track is, of course, give me your model, give me the layer that you are also linking to, and give me the composition, which is where you belong, basically the context. But what you do in the end is just give me the layer because I want to sample it, no? And if we go at in the timeline, we see that we have an implementation for the timeline. We have an implementation of the track. What is that timeline track model? Okay, yeah, we have a parameter, we have an ID, authors we will see. And then the important thing is in a timeline track, we want to describe it as a spread of timeline track items because we want to place keyframes, whatever. No? So we can describe them here. In fact, if you go here, track item, we have an interface for those, and here I can define like a constant value keyframe or a live value keyframe, layer keyframe, or proxy keyframe that it's used. So just to show you that the Kairos timeline is already a bit more complex or richer than layer X shapes because it introduces also, yeah, it comes as a, we can extend this endless, no? But let's say, well, a constant value clip. Let's see the living thing. This is the constant value keyframe, and what it does, being a timeline track item, I can gives me a layer that I can sample. But as you see, this specific keyframe implementation just makes use of layer X, no? Just a key is a keyframe and has a value layer 1D, because this is a constant value keyframe, which means that we probably create this keyframe and we simply set the value there, no? Which is can be stored into the model of this thing. And that's why this constant value keyframe has a model, and I get the value out of it. And that's what it will be sampled, what I will sample actually when I call this value layer 1D. If we go to the live value keyframe, you see that it's a bit different here. Live value keyframe in Kairos, let's say that we want to have a keyframe there, but we want to set the value from our patch. So in an ideal scenario, on top of our timeline nodes, there would be a pin, input pin, appearing so that we can connect something to it. And the value that flows through the input pin will end up here in this keyframe, right? So we need to build a bit of a machinery around saying, okay, we have a keyframe there, and this is our layer that we're going to sample. But the value that comes out of this layer, it comes from a pin in our timeline, and that's why we introduced these timeline items, because now in our Kairos timeline we have more things to consider. Okay, one way is how we feed data from the patch to the shapes, no? So it wouldn't be enough to simply have to use layer X as it is with a shape, no? Because we also need to build around to wrap those basic functionality with something that introduce, okay, the notion of, oh, I'm part of this node and I can collect values from a pin group of this node. So this is already something else, no, that I build on top. And that's why there's this live value keyframe, which is a wrapping of basic functionalities of layer X, like a keyframe, which is a shape, and a layer 1D, which is something that I can sample. Because here I introduce, I not only have this basic functionality, I also know in this context of a timeline where to get my value that I want to sample. And in this case, I'm gonna get it from the input pin of the pin group, right? This is what this live keyframe does through some specific things of the Kairos composition, which we will see as a server where you can ask for sources like input pins or whatever. And in this case, this guy, whenever he's getting sampled, he will ask for the value and will retrieve it from the input pin. Layer keyframe. In that case, is still getting, when I sample this layer keyframe, I still get the value out of one of the input pins, but in this case, I don't get a value, I get a layer that I can sample again. It's just a way to allow me to propagate it, to extend using layer X, like, you know, on top. It's a functional code, simply. So, but these, as you see, these are just different possibilities that we can do. The proxy keyframe is what gets handled by these very high level clips, like a composition clip that introduce many tracks. For if you connect a composition to it, it will introduce tracks and these proxy clips, which don't point to any input pin they just point to the composition, to a specific track of the composition that you plug in. So that's why what they do, they are handled by one control clip of this. So they get the idea of this control clip. They have, okay, this keyframe is meant to represent this track parameters, we say. So we collect the composition that is associated to that control clip, and then we sample that. So, but just to say that these are different ways in which we wrap layer X functionalities, and this is nicely represented here. Finally, we can have a look at that. So this is a timeline track, no? Constant value clip. So the yellow part, the yellowish part, is what Kairos brings in. The blue part is pure layer X, right? So what is a under the hood in a timeline track? There is an interpolator 1D still, no? That deals with the layers under the hood. But then there is an outer level of wrapping because we want to introduce certain flexible ways to generate the values, so that in case of a constant value clip, constant value keyframe, we have a model, and we know that when you sample these, you just read the value there. If we sample this live value keyframe, in the model we store an input pin name, so that we live during the sampling, we can get the value out of this server, which has all the input pins, and then returns that through the layer X architecture. Here is the same layer keyframe. You get, instead of getting a value, you get a layer 1D that you can sample again using layer X, and then returns that, and the same. So you see, it's just a wrapping level to add also this richer functionalities to have. Okay, I want to be able to easily plug values from my patch into the timeline. So I need to, a way to map, these things to my timeline things. So this is too much.
Yeah, that's a nice graph.
Yeah.
It explains it nicely, what is what.
I just thought that I could extend it even more.
Yeah, good overview of the
I
architecture.
could extend even more just to show all the levels, because here there are just two, but there is also alchemics under the hood. With this guy, for example, interpolated 1D inside has interpolate.
Yeah, that's fine.
No? So it could even show that other layer and say, okay, under the hood, there is something here that takes care of blending, composing the background with the foreground, which comes from layer X, but the very deep the essential nodes like interpolation, they come from this other library again. So, but still, here you see how Kairos is really making use of all these other libraries into this onion fashion, which you just wrap around, adding features and adding information, so that you can add levels of handling and new ways to operate on the things, just because you have more information about that. That's also good. Plus, they add also functionalities to that make sense in certain contexts. Like here, we want to have a timeline, which is a node, and we want to be able to plug things using pin groups. So we need to have a way to connect what we plug there to the clips, and that's why there is a server thing. This was the representation of those, and you see, as you see, the timeline track. Why should I just timeline track? What happens there? Just as a model, which we saw now that it simply contains all the items models. Each item is one of those like constant clip or live value clip. But in the essence, it just takes in when I set the model to this, when I synchronize to the model, it takes the model and this functionality, okay, read from the model all the items and then synchronize them. Okay, do I have this clip in the living runtime? No, it means that I just introduced. So make sure the instantiate it there and synchronize it to the model. So they have, in the end, I have some timeline tracks items living there, and then when I need, basically I get the inner layer out of it so that I can use an interpolator simply. So you see that this this layer, this yellow layer, this wrapper around, is just to be able to introduce functionalities like connecting to sources or having already, we could have, for example, we could implement a new item which is OSC control clip. So you put that an OSC control clip, and in the settings you can type control like OSC address, and automatically that clip will listen to a OSC channel and just return the value. No?
Mm-hmm.
So what is that? How would you do that? Well, I would say that that's quite easy, because we know we would have a keyframe. It's going to be a keyframe, and then in the layer we could put the OSC receiver inside. No, so we would wrap this, saying, okay, this is already an object that works in a certain way, and we can patch using these basic functionalities. But in the layer, we know that we'll receive some OSC from network, and we return the value. No, and this is already like a nice building block that I can use quickly without always patching again all this stuff. And or you can have a MIDI clip. Now you can put it there. You choose the channel and the note. I don't know, and suddenly that listen to it.
I asked this before, I just want to double check again. Where do you decide to use a keyframe or a clip?
It's up to you. I mean, do you want to
What's the difference?
So it's just that there's no. We can
The
go
clip
back.
had the duration, right?
Yeah.
Whereas a keyframe is just the one frame thing.
The keyframe doesn't have a length,
duration,
no,
doesn't have
it's
length.
just a position. The clip has something that if you can sample and be over the
Yeah,
clip.
so depending on the data that you want to basically include your.
Depends. Okay, a clip makes sense if you want to have, I don't know, a value for a certain amount of time.
Yeah.
You just put a clip. You
Yeah.
could get the similar result if you put a keyframe at the beginning and a keyframe at the end.
Yeah.
But maybe the clip makes more sense in that case, no?
Yeah, but-
Because
Yeah,
Like
maybe it has
different-
live data. It's not
Yeah.
just gonna learn from A to B. It's
Uh-huh.
gonna be doing some weird thing in the
Yeah,
middle.
yeah.
yeah, you could do still the same with two keyframes.
So the like,
Because still you sample both, and they would generate the same values
Yeah.
that so you would interpolate it with the two same values, and you will give similar. But
Could be like a clip without duration is a keyframe. Behaves. as a
no, actually,
keyframe.
no, you're right.
I know.
It's a function. Yeah, because it's the interpolation is an interpolation of an interpolation. It's a bidimensional
Yeah,
interpolation.
therefore a clip without duration.
I mean, you have the same if you have like a constant value into the keyframes, then you have the same, exactly the same output,
Yeah,
right?
Yeah.
But if you want to build like a function, like the noise that was using the input position,
Must
then
be
it's different.
should be a clip then.
Yeah, I
Yeah,
mean,
is the duration.
I would use a clip because
Yeah,
I want that thing, that source for this amount of time.
Exactly. That's
The
it.
clip, I think, is the best idea to represent that.
yeah, but like, I know I got it, no problem, but I'm just saying that, so what if I?
No,
put a
just
clip- What if I put a clip without a duration, then that's a keyframe.
yes.
Yeah,
Yeah,
Yes.
so could you, for example, use just the clip, then why you introduce keyframe?
In the old Kairos, there are just clips.
You just clip, no
yeah,
keyframe.
keyframe is like a special use case.
And keyframe might
I-
have some video options and stuff like that.
I introduced that
It doesn't.
really thinking to UI
Yeah,
to say, okay, if it's really something different, so the UI can implement, can be like something that
Yeah.
easily, it's a different visualizer and editor for that
Yeah.
thing. But under the hood, there are that shapes that provides a min and a max bound.
Yeah.
So there.
you know, there is this thing in KRL, the Kokarova language, which is super like old and rusty and stupid. But they have one thing I really like is so for raw value stuff, that because there's a physical interpolation, you have to calculate this, that it doesn't matter how much fast you can basically communicate the data, you need to wait until a physical motor turns, put an axis to the other. And then they have two cursors that they one of them, I don't know, they all German, everything is German, so I don't know how is it, I don't remember, but it's like the cursor ahead, the current cursor. The cursor ahead goes like, you can decide based on frame or based on seconds to be how far ahead of the current time. So that goes in future, it walks in future, it sees what happened there. So you can manipulate things in future. And then what current happens is the current data that is happening, which is very weird because you can, and then there is this functionality that you can basically change the relation. And you can also sometimes put them together and then say that increase over time, the cursor ahead goes ahead. And they're using the clip, like when I think of that, it's similar to a clip and a keyframe. So the keyframes could be those basically positions that you send. And the clip is that how long does it take between each keyframe that the interpolation should execute. And there is no time to be empty. There is no empty time in the timeline, which is a very weird concept of a timeline. You know, I was just curious that if it can be reproduced. I mean, this can be reproduced here just for a matter of demonstration, but I don't know who wants to go back to care.
I think that
It's just
to
very
me,
crazy when-
really boils down to the fact that we have a context, one-dimensional space, and we have bodies there, no? And this has a shape which is elongated and goes from here to here, and this doesn't. It's like point.
Yeah, but the clip is an event. Like if you think of a cursor, like if you think of this interpolation factor, like there's
Like
a
when you're-
cursor moving on. Like imagine that, like for example, there is this clip between the green clip and the yellow clip. Let's say there is no keyframe.
Yeah.
There is something that there is no event happening. However, the cursor is moving on, right? If you're thinking of time, like we say that whatever we see here in this interpolator 1D box, the cursor starts and from like in a phase of in a period of 2 seconds wants to go to the end. It starts eventually at some point, goes to the event as a clip, the green one, and then nothing happens when the clip is over. Nothing happens until the yellow clip starts. So there's no even happening.
Well, in that case, I wouldn't use the interpolator. Interpolator interpolates.
Yeah, interpolate between the two. Yeah,
The compositor, for example,
yeah.
works
True.
in that way. If I put a clip there and a clip here, in between, there's nothing. What should be? Well, the background would come in.
Yeah, exactly. It's just that's the background. So that's what I'm
Yes.
saying, that there's an event and there's no event. So when there's no interpolation, where the background happens, basically there's no event like
But for that, I would use the compositor then. Not the interpolator, because the interpolator always fill the space.
And how about that like if I want to have an empty clip, like I don't want anything to happen, you know, like the clip overs, then you say that the first one should be the switcher, or like what is it called, the compositor, and then what is and then after when the interpolation happens, you know, like there are two different tastes, two different flavors in one timeline.
So you want to have both the interpolation between objects or not?
Yeah, I want the interpolation between clip and keyframe, but I don't want anything between
Well,
keyframe.
then I would simply add another clip here that fills the gaps, which
Yeah,
will be
exactly.
transparent.
Yeah, and
So it allows the background to fill it in. So
yeah,
there's no interpolation between here and here. But still, yeah, I mean, you can do it, but the core feature of the interpolator is that fills the gaps
Fills the
between
gaps,
the
yeah.
shapes, I
Yeah.
would say.
You see,
Quick question, Nathan. I remember like ocean of error for these things where you have many patches, hundreds of parameters, and everywhere you have to manually feed in the data that's coming from somewhere, OSC or the model, whatever. How are you doing things in Kairos? Like if you have a timeline with 100 outputs, in a practical sense, what are you doing? Are you passing links around really
No,
like
no, no.
from place to place?
We show it. Let's leave it. Yeah, but this is another version. So let me open with this one. No. Yes. In the old Kairos already, there is this Kairos binder, so to say, that allows you to connect a data type. I imagine ocean of air, massive data type, no, containing all the modules as data types. There was like a control data type, no?
Control it.
Yeah, which was a nested series of records or whatever, where we were controlling manually those parameters. Still, it's a data type, and with Kairos, you said that there's a
Like bind the data type in
Find the third one.
third one.
no, fourth.
Composition tool. Let's try to open this.
I remember there's just like a record that you create.
No, it's not this one. This is inside a composition. Yeah, no.
Yeah, but it was deleted.
Yeah, this is more or just bullshit. Yes. So we see here that we have a timeline. I'm surprised that everything works. Oh, really. This is the model of my application, right? It's my class, which contains a color, alpha, some children, one child. These are the children, there's the child, and it's on creators. Okay, I initialize, no? I can even split and check what's the current state. And as you see, also this binder takes care of traversing, using reflection, traversing the data type. So, okay, I have all these parameters there, right? And it provides this information to the Kairos graph, right? So, and each one of these parameters will using reflections has a path that I can use to write back into that property, right? Using reflections. I just provide, okay, a path and a value, and the API will take care of writing that value into that property of that class. So
What about in the other direction? Because like if you wanted to extract all these values, would you end up with this split somewhere or what?
but that's always the case. I mean, in every, you can still use a reflection here and say, okay, I have a path, I'm building a module, visual module, and I want to have this parameter which takes this path, and then I connect it to my data type. And using reflection, you can always traverse and collect that thing without splitting, no?
Yeah,
Explicitly.
it would be nice to have such a node where you can just some Kairos value node where you just give the path and it works. It magically grabs this value from the graph.
I mean, it's the easiest way that you can do. Like if I have sample channel, right? What is that?
Maybe advanced.
This one probably. Given my timeline, I can always sample it, say, okay, I give you, this is the channel I'm interested into, give me the value for it.
You know.
So you can always directly access that graph. I think that it's meaningful to me to always have like, but anyway, when you build your modules, you're building a graph of objects. Even if you think in the object-oriented way, you have your scene, which is the main data type. The children, one of them is particle system. The class itself, okay, the shader and everything, which is controlled by properties. Right? So this is my entire application is a graph, right? At that point, I don't even need to say, okay, this parameter I want to control it with a get channel from Kairos, whatever. Just patching that thing allows me, using reflection, to from anywhere write into that property. So I don't need to do anything at the point.
I'm able to link them.
I just need the right path at some point to write to target that property. And that's what this binder does. Another cool thing about the binder is that he exposes this properties to Kairos graphs, which means that let's say that we have these what was it? Alpha. Okay, let's remove this one. Right. We have these 3 channels here in this timeline, but we have a property in my class which is alpha, right? If I go to record mode here, now this timeline is listening through the binder, is listening to what's happening into my class. So whenever I change something here, suddenly I have a clip, I have a track that gets inserted automatically, and I have a clip there storing the value.
If you play at the same time, and
storing the value that I'm changing there. So this is the best scenario in which you really imagine from a design point of the designer view. I build my tool and I have a nice UI, to design the aspects of it. And just in this mode, you can simply say, okay, record, keep track. Okay, I'm here in time, and place it there, record, and just start to design. No? Suddenly everything gets stored there immediately. Then I move the time there, okay, record another preset, so to say, in that position, and you just fill it. So super easy. At that point, you can just stay on the very high level, and everything gets routed properly and stored in a meaningful way. And this propagates upstream. So if you have a graph of timelines, in any timeline you can record. So you can say, okay, I want to go there and then record this, and I start playing a bit. If I play back, for example, you see that if I move something, I start to insert clips there. So when I then play back, the value you see is animated here. Because I'm recording what's happening there and inserting clips. So you can, but as you see, this is just nice candy things that you can put on top to keep track of the changes, and then adding tracks and inserting clips. This is something that you can build on top as extensions. No, the architecture under the hood is just that, the same. And we can imagine all different sort of ways to operate. And for example, this example that I said is similar to what we could imagine as a preset system, no? Which is a matrix, no? You just go to the first row, you select the first row and go in rec mode, and then you just simply start playing with your tools and setting parameters, and everything gets stored into that line. Then you go to the next one. And then at any point, you can play back those, right? Or individual clips for just, okay, all I want to trigger the first parameter, but for the first preset, but then for the second parameter, I want to trigger this clip, which is in another preset. You can get fancy, no?
Just the color of the first one, but the sound of the third one.
Exactly.
Yeah.
So it's really up to you to build tools on top that allows you to have higher and higher ways, levels of operating on it.
Moment of reflection.
I'm exhausted. I think I need to have a break.
Yeah.
Let's have a break. I'll pause the
Ah,
recording.
wait. Is there any question? No, I think there's no one left.
Just
Now,
three.
just surrendered. Everyone surrendered.
So I'll pause the recording.
So everyone. The problem is our voice doesn't go there, so.
Okay. We are back. I would suggest now that I show you some patches. Just to, see. Timeline, what is a timeline? In Kairos? It could be a composer, but what is a composition node? This is the current implementation of a timeline. Or what are the key parts of it? I would say is that there is a model, because since we are not anymore patching and building these graphs through using nodes, we need to find another way to store, to serialize these graphs, no, somewhere, because we don't have anymore the nodes. The nodes in the patch, the patch is serialized, is the source of the graph. So that's why we need to have a model, which is a description of our graph, that we need to store somewhere, and then it will be used as a reference to instantiate and update a runtime aspect of the software. And that's why we have a model. If we go to the timeline, what you see here, we have a list of tracks and a list of controllers. Later, we'll talk about this. But just to go back to the essence of what is a composition, it's basically a collection of tracks in the essence. And so the timeline needs to provide a description, and we can add more features to the composition.
Sorry, what are we calling controllers then?
Forget about control. Okay, have a look later. So Kairos core is the part of the library that provides the essential interfaces and functionalities. And the basic, very basic interfaces that we have are iComposition and iComposition model. iComposition is something that I can ask for a model stream, which is something, it's a model basically of a composition. And I can ask tracks, I can ask controllers, server, and the node context of this specific instance. We'll see. We'll go into details later. And the model, as we say, has a bunch of tracks, has a series of extension methods in the interface itself. So they are just operations that operate using the interface itself. So we don't need to implement all these operations in all the implementations of this interface, right? I could, if we go back to the, so it's a trick to basically, I have the tracks and I want to operate from the tracks in many ways. No, I want to have functionalities to get a track, clear tracks, add a track, set the value of a track, whatever. No, but I don't want to implement this. This is the interface.
Yeah.
Right. I don't want to implement all these functionalities in every implementation of this interface. Right. If I want to have those implementation, I would need to go back to my timeline model, and for the tracks implement, okay, add track, no, set items and whatever. So every implementation of that interface would need to implement all those methods, which are very generic.
Fake inheritance.
Yeah, it
Yes,
feels like
yes.
it, no?
Yeah,
But it,
exactly. It's faking inheritance somehow. Using this trick of the extension methods, where you define functionalities that operate at the interface level. So any,
One little thing here.
you can't override.
No, when you now use it, you would always need to backcast your model.
Yes.
Make them generic and type them T model in, T model out, and then you have it nicely when you connect them outside. It will propagate
Good point. Yeah, yeah.
properly, and it will stay a timeline model.
Amazing,
And it will
amazing.
stay
That's a good one.
compositor model and not.
That's a good one.
Now I'm out of- I'm
Yeah,
lost
doing
in-
like
what
that.
is this outputting in C sharp? Is it like a static method that on the interface definition? Or is-
Yeah. You can, you typically,
Oh, you can.
in classic C sharp, you,
Now you can.
write a static,
I think we can do that.
and a static function. And the
Do
first
it half.
is your, and just to make it easier.
Still do it last year.
Still, it's half, yeah, of course. Set, wait,
At the output.
set, no, because I need to do it also here. That's the thing,
And you want to
right?
dot at.
You need to put the cast somewhere, I guess.
Then you, in order to make this work, you have this keyword, and, so the first.
But if you do it like that?
your Static function would be this icon position. Blah, blah. But that's just sugar for C sharp.
You need to cut the output.
Yeah, all of them.
Irrelevant for VL, if this
Put it
keyword is there.
in.
Oh, no,
You
but
always know.
No, right before the output.
Calling
you
it. Yeah.
That's all, because that's the problematic part, because that's the
I've
output.
seen this done.
hard cast.
You know. So it is the.
These are just static functions.
That's what I do usually.
So this more than an
Outside.
interface, it's almost an abstract class, you know,
We need to do it
that
this-
has some things implemented, but some not. And conceptually.
Now outside, it's nice to use them.
Yeah,
These functions. could
okay, this is something that we, yeah, I just
define,
copied from the old
outside
file,
this
so we need to
interface.
correct this.
Okay, so these are just static functions that are categorized in a certain way so that they end up in the node browser on a Kairos core icon position model. And then there are these operations.
Yeah.
But it's just because not to put them onto that canvas here, into the, yeah, but actually
They're not type
You-
operations.
you can do this another way as well. You could just create a new on a different canvas, on a different VL document. We can just create a category thing, call it kairos.core.icomposition model, and place all these operations in there, and they would also end up in this category. So,
Okay.
but then this is just the aspect of categorization. So where they show up in the node browser.
But
And
anyway,
but these are just in the end static operations.
And what was the hard class actually?
yeah, because
So, yeah.
the output of this still.
Yeah, I got that
position.
one.
But I mean, hard cast means if this node, the cast would not succeed, let's say, it would turn pink, it would throw an exception. But in this particular case, we truly know can't fail.
Yeah, because
What's inside actually?
So it doesn't have a try catch or something.
It does.
It does, no, it throws the exception, that's why it's called hard cast, like.
But
Yeah,
there is a
you
try.
should be sure about it.
There's a try. Sorry.
No, there's no.
There's no.
There's no try.
There's no. Yeah.
Really just.
So anyway, just to say that since we implemented all these functionalities at the interface level, we don't need to implement them in every class that implements this interface. We just need to implement set tracks and get tracks, because these are the two operations that will get used with all these operations inside. So once we implement these two operations at the interface level in our timeline model, then we can use all those functionalities over this implementation of interface, which is quite convenient, no? It boils down to nothing then this timeline model. Okay, icon position, as I said, is you can ask to any of compositions like timeline, compositor, or whatever, compositor 2D, state machine, whatever, to Kairos tool. You can ask a model, channel, like a stream. You will see why it's a channel or a model. You can ask tracks, controllers, server, whatever. Let's go back to this. So this is the timeline. Obviously, it implements eye composition, and that's why I need to implement all these functions to retrieve node context, model stream, tracks. As you see, they match it. They match with the interface, because if I disconnect, still I have a specific type. That means that, okay, they like implementation of that operation of the interface. So yeah, these are the parts. Then we have server and a processor. So let's go, model stream. Back in the days, I did this tutorial where I was talking about model and runtime pattern, no? Which is a convenient way to this description of a system and then the instantiation and runtime of the system. And back then I was using this, I was wrapping a model, which was a record data type, immutable, into a reference, which is mutable, which means that I was carrying around this reference of this model. So any editor could take the value out of this reference, operate on it, and create, add something there, and then write back into that reference, no? So it was a way to still have this nice functionality of the immutability of the data type, because we know that if you have a nested immutable graph, if you change something there, then you have nice, you can track nicely where are the changes, and you have snapshots of this. It's nice to have a system description with that kind of functionality. But still you want to bring it around everywhere, because you want to have many editors operating in it. And then you just need to make sure that your runtime, every time there is a change into your model, synchronize to it, right? So in the old old Kairos timeline, it's still over now. I have this reference of the timeline model, and the runtime was every frame was getting the value. Okay, I was checking using some cache regions. Is the value changed? Then, okay, if it changes, then I need to go into a synchronization routine where I go to the model and say, okay, these are the tracks. There's a new track. Okay, let's go there. Let's make sure to create this track. And that's a synchronization to the model description. But still, that was happening in update. So every frame I was checking the model and checking for changes. Now there's a much nicer way to have this model wrapped in a way that you can edit from everywhere, but still and also have more information about who is editing this model and when. So that's why we're using this channel node, which is now available in the version 5 of DL, which essentially is like a behavior subject. It's something that you can observe. It's like an observable, which means that it's something that triggers events, right? So anyone can take the model out of it. You can always get the value out of it, modify something, and then push, and this will trigger an event. So everyone else that is synchronized and is watching, and eventually, like the runtime, not only can get the value and read, but also get the notification when that's triggered. And that's the beauty, because if we look at the processor here, this is, as you see, is the processor, but it's like everything is in create. Most of it is in create. Why? that the synchronized to model routine, I can define this on create and saying that since the model is unobservable, I just say, look, for every event that comes in, I want to synchronize the tracks and synchronize the controllers. This is the model that comes through the notification. And this is then synchronized tracks. This is what happens inside. It gets the model and gets the tracks out of the model with a cache region. If the tracks are changed, then it goes into this synchronized to model routine, which is like a functionality that goes through the tracks. And yeah, check if they are available and check the items that are inside the track, like the clips, whatever. If a track is not there, it calls this create function through this delegate. So here you can define how to create a track, no? To instantiate a new track. And then here you say, okay, once you have a track, this is how you write the model into it. And this, all of that is defined and create. I just need to construct this routine and it will just operate event-based. Okay.
So essentially you're subscribing to the events here on create and then they get triggered at runtime.
Well, yeah, whenever it comes an event, this things runs and synchronizes.
Interesting. So
Right.
this is more like a definition. than-
Yeah, exactly.
Which is weird. Okay. No, it's kind of weird that you know. Because the idea I had of create is this
We
thing
can
that
talk
gets
about
run once
Well,
when the patch starts.
doesn't explain
Otherwise we have this
very nice way.
which we need to track down.
An observable, you describe what will happen in the future.
To put it disposed.
So you
Right,
explain
right.
when this happens in the future, I want this to
Because
happen.
here,
That's
what
what you
happens
want.
is that they don't get disposed.
Then this,
You need to do that
when this happens.
That's what is
Again,
it thought.
this is like plus
But
equals
why?
my
Yeah,
event
the player
handler,
should do
this
that, no?
Thing, my code
Why
is
not?
there, and this is getting
Yes.
called. When you assign an event handler.
The connection
That's-
know that it's the only.
What about
You will need to have like an
Of this problem, what should happen in the future.
But then we can,
On a nice way.
then we need to, yeah, we need to show you the sense. That was the.
But this is not true when it's not observable,
What the
right?
fuck, why they are not
Create is just a
deleting
one
really
time
their
execution
keys?
thing.
Because they weren't disposed.
Yeah. And if you manage things dynamically yourself, you need to dispose.
Okay, good to know. So, okay. So this gets constructed on create, this routine, this synchronization, and that's it. Then we have same sort of synchronization for inputs and output pins. And also we have like this composition model pin update, because when we have a timeline, we want to store the model, we want to serialize the model, no? We build some tracks and clips, and we want to close and reopen the application having the same stuff. So we need to store the model that describe this graph somewhere. The way we do it, it's writing it into a model here, into a pin of the nodes of this instance. So there is a model pin here. And by building this through this patch, I simply subscribe to the channel of composition model and filtering a bit so that we don't write every interaction that we do, but just maybe with a threshold or whatever. But then we take the model and write it into the pin of the node, which is this name.
Which in turn means it will make it to this file's XML, yeah? Or no?
It will serialize using the VL serialization, right?
Yeah, but it will write in the very outside, so in your user patch.
Yes.
Yeah, it might be a document, it's where the whole model will
It can be, yeah, you can serialize and write it as you can serialize it anyway, no?
fair.
And store to a file that you can load and dynamically and push different things to it, no?
But here we're doing it in the patch.
Yes. Okay, so this guy takes care of whenever the model changes, it updates the model pin. Then these other two synchronize the input pins. These are the resources. And then we have in the track, we have some dynamic keyframes or clips. We're gonna have the inputs so we can plug values and route them to the clips. So there is a pin group there that gets updated. Now I'll show you the mechanism. Yeah, and then we have controllers. There are another kinds of objects that you can use in the composition. So there is a server here. Server as resources is just a dictionary from string to object. So you can just add any sort of resource to this composition, and every part of the composition, every clip error can access a source. Just need the thing. Then we have input pins, and this is literally the input pin. It's a pin group, okay, which shows here. Now, this is, for example, is one of the inputs because we plugged we asked for a pin, and there's a pin here. This is this pin group, which then gets passed here and get everything everywhere. And then our composition can access the server, ask for pins, and even retrieve a pin, one of the input pins. Okay, and that's what happens in in our live value keyframe, for example. No, this is what it does. It gets the server and say, give me one input pin value. This is the key of the input pin that I'm interested into. And what it does is just through the server, just use this function to get a value out of the dictionary that is the input pin groups.
How does it add one?
Huh?
How does it add and delete one?
This is this pin server here. So whenever you need, like when you instantiate this live value keyframe, it means that you want to have an input, right? And in the model, there is the only thing that is really relevant here is, okay, I want to have a pin with this name, right? So when this live keyframe gets instantiated, this is the runtime. When I set the model, I have this input pin registration node there that takes care of this part here, talking to the server and say, look, I want to register a pin. I need this pin. I need this pin, which has this name. I am this client, and this is the type for it. And you see this pin server, what it does when you receive a request, this register input pin says, okay, I received a request for a pin, and first it checks, does already exist a pin with that name? If so, it means that this client is just wants to connect to the same thing there, right? So I don't need to create a new one. I can just return the key for it. If it doesn't exist, then a new pin, I need to add a new pin. And that's why I have this this local dictionary of pins.
Is this pin model your type or is
Yes,
it
yes,
the other
yes.
thing?
No,
Because
no,
you-
it's my type. Where I store, an ID, a name, because I also wanted to have like to prepend something like if we go, sorry, go back there and then jump here. I wanted to, since there is still not a nice way to, let's say we have a timeline with many clips, dynamic live value clips. Still, you will have a lot of input pins there, and it's always a mess. Okay, search for the right pin that corresponds to the clip. In an ideal scenario, we'll have some features from VL where we can highlight, for example, certain pins in the UI. We say, okay, I want to highlight that pin on that node. So whatever the UI will operate that, whenever we click on a clip, it would highlight the pin that is connected to. No? That would be an easy way to have very immediate and obvious connection to the patch. But now we have not such an option. So I wanted to at least have like a number in front, so you can at least navigate and they get sorted by the number. So it's easier it's faster to track that.
Okay.
So, so this guy, yeah, you can assign a name. I am the client of this pin, so to say. And there could be multiple clients also, because let's say the two clips are the same pin, the same name. First one creates the pin, second one connects to the same pin. Then you remove one of them, and the first one, and then you move also the other one. Means that this pin doesn't make any sense anymore, so it can just be deleted, right? So this is taking care automatically this registration. Obviously, there's a type there, and if it doesn't match the type, even though the name of the requested pin is the same, but they're asking for a type with different pin with different types, that's a problem. Which shouldn't happen. So what you get then when you subscribe, you get a subscription, which is this class here, which you get an instance of this class, which disposes itself by calling this delegate, which is the unregistered pin operation of the same class. So you don't need to call back anymore this pin server when you want to dispose yourself and you're not using anymore that pin. No, you simply register the pin and you have a subscription. Then when you kill this patch, you will dispose this patch and you will call the dispose of this subscription that internally will trigger this function that is already talking to the pin server, right? So you don't need to care about that. But anyway, this is to say that every time we ask for a pin or there's a new thing, this get compared with the existing one, and then you have a new dictionary of the current pins, and this get pushed to this pin model stream, so that from our side we always can get this input pins model channel. I need to rename it. Again, sorry, this is stream, and this is for the output pins. And so back there in the timeline, in the processor, sorry, just close your eyes, right? In the processor, we have somehow a similar thing that what we have with the model. We have this routine that synchronizes the actual node pins with the pin that comes from there. So here, for example, is the input pins synchronization. From the server, we get the input pins model channel, which is this stream of the model of the pins, and we react to it. And when we get an event, when someone registers a pin or get created or deleted, whatever, we get a notification, and we react to it, and we synchronize them. This is what we do. We simply go through the dictionary of the pins, get the values, so sort them by the unique ID. It gets computed, which equals the number at the beginning, and then we synchronize the pin group. So we just get the pin models, get the unique name, get the full type full name, and we add it to the pin group, and that gets basically written to the composition, because we are passing also the node ID, the context, and the node ID of the node.
Okay, so this is basically getting the VL graph back in line.
Yes.
Yeah, okay. So this is synchronizing the VL patch to the Kairos model, so to say, or to the composition model.
So that
The other one was, yeah, okay.
So this is, you see that now, for example, you can see here that there are two pins. I just manually put it there, this input pin registration thing, which is inside the clips, no? But I just for testing, I put it there. And as you see, I can register a pin like that, will appear here, and also there will be here, no? A new pin. I can unregister the pin, and it will disappear, no?
But it doesn't make the node go thin again.
That's
It's really annoying, you know.
Why do you have it like that?
Showstopper. But the system also takes care, as you noticed, because when you change some of this, I need to get rid of it somehow, but what I was saying, yeah, when you register, if you change something, also unregister the previous thing that you had. Like for example, if I'm here, for example, I'm constantly generate random names for this, right? So whenever I trigger this, it will first remove the previous things that we registered and then ask for a new one. Like you see, no? It's just removing the previous pin that was registered by that actor, the client, and also asking for a new one with a different name.
connect the timeline, because then we should see a red link, no?
Where?
That's what I also.
Now delete it.
Why is it necessary to remove it and create a new one? Why can you not just?
Because
update
every
it?
time I can't modify the keys of the dictionary, right? I can't like root them. I regenerate the pin groups.
But this is because you're using the name as a key in the dictionary. If you were using something else, like a hash or something, you could potentially update it, no? Never mind.
No, but it's interesting.
I mean, yeah, I would need to introduce and check if it's consistent, like and preserve them.
But if you were using something other than the name, you could also have multiple pins with the same name and different types, which is probably a mess anyway, but it would be possible, right?
Different,
Like a pin, two pins that are called color, but one is our GVA and one is a float. This could
not
then
really,
happen.
on the VS side it's not possible. Because
Really? You know,
This code will not.
because the pin group is the dictionary.
Yeah.
as all.
So the
Okay.
key is unique there,
Yeah, the name must be unique.
must be unique.
Otherwise, you would have two color pins, which is just.
Yeah, you can
No
do that.
sense.
I mean, yeah, it's not a great design anyway. Okay,
So just to say now,
I didn't understand. Did the pin name actually change or?
yeah,
Okay.
from this one we went there, no, like from this one was, we
Okay.
remove this pin and create a new one.
It was just not clear, this example you gave.
Okay,
If you would now copy this thing just for a second and connect it to the same timeline and feed, let's say 23 instead of random.
yeah, I mean like 99, right?
Or 23.
it's a very specific test.
You did it on purpose, so you know. Yeah. Michael Jordan, so like
23, and I was just wondering if there are two of these actors
A random 23.
that both want to have 23, and one of them just unregistered. Will it still stay around because the other one still needs it?
Hmm.
The question is if
wait,
registrations, if you
no, it's fine, because here the client is the same.
Yeah,
okay.
you would have a different client.
You would have different clients.
Yeah,
Sorry.
okay. Yeah, restart.
I don't think I need.
Okay.
I need probably, yeah. One other thing is that every time I stop here with this patch, it takes ages to go to stop. I don't know,
Because it crashes.
probably disposal
Yeah.
thing, no? Now we have two, nobody asked for anything. Now we'll register this one.
Okay, let's take 60 there as well.
No,
Issue 60.
yeah, but this one didn't come in at all.
Are you sure?
Type full name is not showing anything.
Yeah.
But it can be like an
Right.
RG, like an iWorks bot, maybe.
I think something is. No,
This window is constantly popping up, the arrow window.
yeah,
Okay, so
but I mean. It works. Clearly,
Especially for random nodes.
As long as you don't use 23, it works.
It works because the clips,
Yeah.
they work, no? They ask for different values, no?
yeah.
What is Chicho?
Yeah.
Yeah, it's crashing constantly.
Sorry.
Something.
It's not
Yeah.
recovering,
Probably not you.
probably our fault or my fault.
Yeah, we need to have a look. Let me, for example, let me.
Not your fault, at least your responsibility now. It is known.
Just reopen this batch.
Which version was it?
5, like the, oh no, sorry.
What?
Oh no, because it was open before, okay. Yeah, is already not a good sign. My works.
But you need to have the same number in this guy, like the one that exists, so 25, for example.
No, you want to have 23, yeah.
No, but it has to be one that
Really
exists.
similar.
Oh, we had it 23. So that's,
No. Why? Probably crashed again.
Don't put 23. You knew it will do that.
it's the code base, if 23
Crash.
throw exception.
It's still the same client.
Yeah. But now it's unhappy again.
Nice work.
Is it?
But I wouldn't even know what should happen, honestly, so.
I think no. Since this whole thing.
Maybe it's working.
Like,
The idea would be that both want to have the same pin. There's just one pin and they both access the same pin. If one unregisters
Still
and registers a new one, then you suddenly have two pins.
Mhm.
But the other one is still used by the other one, and it's not broken. And because there's still one subscription to that, and so on. But
Okay,
probably
I understand now what you wanted to check. I was looking at another thing.
it's a traditional resource management, lifetime management
it's
thing. And you want to have it to survive over one frame and not die in between, and then to,
I want to make sure that,
you don't want to have it die and then come up again.
No, but you had the clients, you were checking for the clients, no? You do this ref count with the client's pad inside.
everyone register a pin and that pin get created and in the model of the pin stores who is the author of that. And you can have multiple authors, clients. So as soon as you have clients for a pin, it still exists. It's preserved.
Exactly.
In the moment,
You will
just
only delete it if
wanted
there's
to
only one.
demonstrate that your system does it.
let's try it.
You have a kind of, if you basically put in the calls in the wrong order, like unregister and then register again, it could be that it dies for a short moment, the pin. No? Isn't that what you were aiming at?
No, because what counts when you unregister is simply the first thing that it does, look,
Check the clients.
what really happens there, when you unregister, you remove the client ID. And then if there are no clients,
Yeah,
you remove it.
this has no clients should be.
Yeah, it's like a rep count. That's what I mean. It's in the end, if the rep count goes to 0 for a short moment, it dies. Even though it would come up again to 1 in the next fucking nanosecond.
No,
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 Language, there are kids watching it.
no, because you have a model stored there with a spread of clients. And you just unregister one of them, but the spread is consistent. It's just there's something there. It's consistent, the model of that.
But I think that if that pin is being used and then you kill, wait, how was that? I get this, you explained it, when you deregister it, like when it does exist, and another resource is using it, when you deregister it for whatever.
This is exactly why to prevent that. With this system, if there is anything that is using that pin, it's always present. You will never die.
Show us.
That's to okay. Let's try again. Let's try again. So
But
same input pin name,
Different
okay?
clients.
Different clients. We register it, and we have it there, right?
There it is.
Yeah.
Now
We
the other
could
guy-
even clients. We can even check the clients. Okay. So we have 3
Why?
pins. Okay, this is
Oh.
the second one has 1 client. Now we register also this one, and suddenly we have 2
Wow.
clients for that pin. I unregister this one
And still.
and still have this client, and then I unregister this one, and the pin is gone. Some, yeah.
What happened then?
It
What?
was the wrong version of Gamma.
It was wrong.
No, there are some inner things that we need to fix.
Okay.
The one that you
Good
just
for you, it's
mentioned.
not the, everything is fine.
I didn't know that when you clear an mutable dictionary, you're not disposing the object. You need to manually dispose them.
The objects inside the dictionary?
Yes.
Ah.
I couldn't expect that, but by patching it, I was saying, yeah, like removing some clips in the model, the pins were still there, so I was saying, what it means that they don't get disposed. It's the function to unsubscribe to the pin doesn't get called, means that they are not disposed. How that's possible? Then you just told me that you need to manually dispose of those
Oh, that's
objects. Yeah, I never. Yeah. So I think that this is a solid pin system now that we can rely on, and it's quite generic, and that you can it's already getting used from the live. For example, a value clip asks for a pin because it needs a pin, and this guy returns a pin key also, because you know when you register, you ask a pin with that name. That is not the final key that will be in the dictionary, not because I wanted to have this
Number.
So you say, okay, you registered, you wanted this name, and this is the final key that you can really use to retrieve out of that dictionary what you need. Comes out here. The convenience of this is that you don't need to do anything else, because internally into this input pin registration, inside here, this type that really talks to the server asking for pins, also make sure to, when this class gets disposed, you unregister the pin. So whenever you kill this clip, this key frame, automatically it will take care of unsubscribe and unregister the pin, right? So everything is handled by itself at that point.
Very clean.
Okay, so back here in the processor, we have synchronization to the model for the tracks and the controllers, synchronization of the input and output pins, synchronization of the model of our composition so that we can store it, serialize it into a pin in our instance. So what's left is controllers. We have an update for them as well. So I was thinking, if we go back to Miro board, the old Kairos, no, we we say that we have these composition clips, no, which are clips that we can connect to other compositions. So they are like placeholders for something else that will come from another composition. And these composition clips will take care of inserting some proxy clips into the tracks and aligning them, targeting to the tracks of the upstream composition. Okay, so but I was thinking, okay, what is this clip here? This contour clip. Somehow it's an object that wants to take control over my local composition in some way, right? So I generalized that in that sense that the controller, it's something that has access to the mod to the composition and has a model. And it's really very generic, but in the case of the timeline, for example, we have a composition keyframe. There will be also the clip to get back the behavior that we are used to from the old Kairos. No, where you can place this very high level clip that you can plug composition to it. No, and this is just something that wants to take control and operate on the model of our composition, because that's what happens. And I can show you composition keyframe. I try to generalize as much as possible. Also here to simplify the implementation. This composition keyframe is what connects to the other composition upstream. No? So I made this sync to upstream composition change. I should rename model. And this is the machinery really that takes care of getting this composition up here, getting the tracks, comparing with the local model, making sure, okay, I have this track here, I have this track there, perfect. So I can just insert a clip there so that I can inject what comes upstream into this local composition, as we saw, no, in the example of the Hamilton there. Or if it doesn't, here there's a track that doesn't exist down here, I need to create a new track and put this proxy clip there. So from downstream, I can still get access to the channel there. And this is, yeah, this is the machinery, and it's very clear what it does. First of all, it creates a pin, because whenever you have one of these composition clips, you want to have a pin where you can connect the composition, right? So you want to register a pin, and then the type will be iComposition, right? We want to connect a composition to it there. And then we have this process node that takes care, okay, we get the composition out of the input pin dictionary, and we check, is it really a composition? We should, but let's check. Okay, and then what it does also, it gets the tracks, just to completely make sure that we are dealing with something that is meaningful for us. It gets the track and it compares the inner, every track is a layer, no? So we say that if we have a timeline, we have tracks, and each track contains a 1D layer, right? Because we are in a 1D domain. So I need to make sure that if I have a timeline, I want to connect another composition upstream into this one, that one that wants to come in needs to be 1D. How would it be otherwise? No, it wouldn't work. I'm in 1D domain, layer 1D, so I'm sampling using 1D position. Everything that is upstream needs to be a 1D layer provider, so to say. No? So this guy, that's why this patch is like generalized, so that you can define here, for example, track inner layer type. Here I type I layer 1D, so I just accept compositions from upstream that internally deals with 1D layers. Otherwise, I wouldn't know how to relate to those. Okay, this is the first check.
Two things. The
Mm.
cache region is enabled.
Of course.
Yeah, just
The other one, the chat says 8 messages. There are 8
Oh, that's,
messages.
yeah, those are not
Service is taking care of it.
talking with people.
one thing that's problematic, I couldn't use this warning.
Okay.
Because they accept a node context on create. And I don't have this on create. I can't access this when I create, when I instantiate dynamically this class.
Okay,
But anyway.
one simple trick is to put it in a manage process region. Always if you have something,
Okay,
only
Just
on
wrap
update,
it,
just
yeah.
wrap it in a managed process, and you postpone the create part of your
Or-
process mode.
or even in a repeat region with one iteration.
Or an if region. I
Even if-
think should also do it.
Okay.
I guess the matter process is a deep.
Yeah, I don't feel it has more, it kills the state also.
Oh, okay.
Anyway, this node takes care, okay, we have now finally a meaningful composition, right? And what we do then, if it's valid, we just get into it, if it's valid, we get the model stream, right, from that composition, so that we can construct, again, using the event, we can react to the changes of the model of the upstream composition. So whenever you change something there, I need to call this routine to make sure that I react to those changes and eventually synchronize and change my local model here. Okay, and this is what it does here, basically. Unauthorized, uncontrolled tracks. I even put some descriptions here. But yeah, this is the machinery that takes care of synchronizing the tracks upstream with the local tracks. And the cool thing is that I really used to, I use delegates everywhere so that this patch just takes care of this alignment and creation of tracks without caring of what kind of tracks and what kind of layers they own and whatever. Just takes care of these logics around handling tracks, so that from outside here in the composition keyframe clip in specific to timeline, we can say, okay, here we know that in this domain, first of all, we have 1D layer, and then I know when you synchronize, you see remove layer proxy items function, which means that when you kill a track, or when someone up there remove a track, we need to go through and remove some clips. Then I know here how to search for items into my timeline and how to remove them. Or when I create a new track, I know how to do that because I know that I'm a timeline track model. I can get the items, and I know that I wanna create, proxy keyframe in that position and so on. And these are all specific things to the timeline, but still, this is very generic, and I could use the same patch for a composition. In the compositor 2D, for example, I could easily implement the same machinery that synchronize upstream composition with my local composition, just describing what to do when it's needed. And this is the essential things that are needed. What to do when you to remove the layers, what to do when you want to create a track. Here we are creating a timeline track model. No, in the compositor 2D whatever, I would create a compositor track model. No, what to do? These are just the specific things that are needed into this context to synchronize. So it's very easy at this point to reuse this machinery into other contexts. You just need to describe precisely, specifically how to operate in my context, providing these few operations here. So, and this is a controller, because in a way, it's just something that wants to operate on our model or do something. He wants to do something, not even operate on it. You could have a controller that doesn't even operate on the model. Just simply, I don't know, display a code in a schema render. I don't know. It's very generic. You can implement any sort of controller. The thing is that controllers can have a lifetime, so that they have an update, and they have access to the composition. So we can extend, we can build any sort of controller that working.
I didn't get the example, what could that controller do?
Just create a window, a schema window with a code
Oh, okay.
that rotates.
So a controller is just a module that has access to the composition. Module.
Yes.
Okay.
It's just something that has access to. It's like a component.
Yeah.
You can imagine like something that you can that you can give the model for.
And where is it? Where is it hosted, or who owns it, or where is it?
It's part of the timeline, right? Here, tracks and controllers.
Yeah.
You have a mutable dictionary of controllers, and they get synchronized to the model because, as we saw, there is in the.
Sorry, what was your example now of a controller? Like, for what was your, was that just the composition? No. What was your,
The one that I implemented here.
no, it wasn't about the renderer with the moving forward. What was your example?
We were in the composition keyframe. Was that a controller?
Yes.
Can you show again? Does it
Yeah,
implement
because I
like
also
controller?
lost now, if you can just,
So this one, you see in the old Kairos, this clip here is not something that exists in the tracks, right?
yeah.
In the back in the days, that was a control clip. But now I generalized, saying that's just something that, in this case, get a pin and synchronize an upstream model to the local model, right? But in a way, it's a controller that in this specific implementation synchronize two different parts of this graph. Huh? Just one possible controller. Another one could be that instead of creating a pin that allows you to create it, it's synchronized to, I don't know, to network. I don't know, depending on some channels that arrive via OSC. I don't know. It creates channels for those, right? But can be
Back to the patch.
back to the patch. Timeline controller. This is composition keyframe, and this guy is an eye controller.
Okay.
Yes, and so he gets the access to the composition with everything, and as a model, so we can serialize. It's part of the model. We can, when we store our composition model, includes tracks and controllers as well. So we can store, no, and instantiate those controllers into our model. Yeah, so we have a model. In this case, what it has is timelines item settings, which is like position, and because in this case, this particular case is we want to have a keyframe there that is connected to another composition. So we want to locate this keyframe somehow. We want to give it a shape somehow, and yeah, this timeline item settings is nothing more than like this. So I have min, max, bounds, because we want to operate with it in a certain way. We want to place it so they go. Yeah. And also as a composition input pin name, so that when I instantiate it, we create a pin where I can connect the upstream composition. And then it takes care to synchronize to the model. This is just one controller. Let's say.
Just a reminder, guys, that we have the community call at 7, and that's soon as something to present.
Yes.
So yeah, just if you want to have a break or something, take that.
Yeah, I would take a break now. you see, it's in a way it's quite essential, no? The design of this. It's not that crazy. Just implement the okay. This is an extra that we are not using right now. It's just, but we will soon use, like maybe you can attach clocks or I don't know, tags, or you can add, right? For example, when a timeline here use another time up there, it can add itself as a client, for example. I don't know, you can imagine. Just that's why it's very generic, these sources. But then the essence, yeah, is that we have a model, we have tracks and controllers, and the rest is functionalities around.
It's quite sophisticated, I would say.
And that's why I can go back now, we can understand better this graph, no? Where I was saying, okay, we have a timeline and then this live keyframe. Then when we set the model, this is the node that register, talks to the server and asks for a pin, and it returns the actual input pin that we are gonna use, and then use that to get a value out of the input pin that is still provided by the server. And that's the final value. So that's why we are talking to the server from there. Same here. In this case, this clip doesn't talk to the server. This is a proxy keyframe because it's the controller itself that asks for a pin and creates a pin. And then this proxy clip just talks to the controller saying, okay, you created me, and I'm supposed to instantiate one track item from the upstream composition. Give me the composition that you're connected to, and I will just, okay, you give me the composition, and I will collect the track that I'm supposed to sample and just get the layer and sample it, right? This was yesterday, but
This serializes to a pin. What happens when I export the application?
It ends up in the DLL as a constant.
String, yeah.
That's
Because
great.
so it's rewriting the DL into the DLL every time I
Oh,
change the string.
Wait, no, that wouldn't work. It's frozen. I mean,
If it's a time I'm
Some
creating trouble.
elements of that system are not working for the exported case. This is more really crafted in a way that it works well in the VL runtime when editing. So that of course it would be interesting to ask, can I have this timeline and in a different version, so that I can use it as a external tool, as a executable or as part of my project, or I don't know. But for that, some parts would need to change. I mean, it's just not meaningful to store stuff in a pin, because in an exported app there is no
a pin.
but it's so easy, I'm just going to react to the model and have a node that simply writes to a file and make a change. And then, so.
No, it's just been
The model is written, like this thing you built there, it's written into that. Where is it written to? Into the instance of the timeline. Yeah, into the timeline node.
Yeah.
So when you export that patch without the editor, that model will still be deserialized and runs, of course.
Yeah, but when you, like, if you have a UI that lets you add new tracks and things.
That will just, the calls would just be empty, it would just not do anything.
But at that point, I wouldn't use an executable for that. I would even think, okay, I have an executable, which is my application, that I can talk to maybe via network, and I have my control system in Kairos, where I can still edit and because when if you want to edit and you add a constant live value keyframe, which means that creates a pin, you want to patch something that connects to it. We are talking about the VL editor here. You wouldn't be able to do that in an executable version. In that case, you will need to build a tool that allows you to, for example, have a node representation a new node representation of this operators like timeline, where you can see an input pin and you can add operators to it. But we basically need to create a runtime exportable VL version somehow. No, like yeah,
No, I was just curious what would.
it's possible, huh? But if I go in that direction, I would more imagine forget about recreating VL and all these possibilities. In that, if you go in that direction, I would think more like, okay, let's enrich the collection of items that we can put into the timeline. So if we want to connect to an OSC input, we don't need to create an input pin there and then put a VL node, OSC receiver, and then connect, because we couldn't be able to do it in one time. But if we prepare an item like a clip, which is an OSC message clip, then that's something that we can instantiate in an exported version, and then we can configure it, right? And still we have the same functionality. We can't define that functionality outside because that's a frozen graph. It's software, but still you can extend it, no, and enrich this tool. Just adding new objects to it, new items. Still, yeah.
Wasn't our very stupid question, when we at the lake had the first link, wasn't that the idea that we could put any node there into the fact?
Yeah, we did it, right? We put another code.
That was, I think, the thinking, like we could put any VL node into the diamond.
Patch in the track,
Yes.
an editor in the track.
So yeah, I think we can stop here. Is there any question?
Not in the chat.
Internet people, any questions? I think. we'll
Internet
have
people
Ari
is
now.
Internet Ari.
Internet Ari. Hello, Ari.
Should I call him?
Any question?
Okay, so
It's a good, strong introduction. I wouldn't say I got every
Everyone
detail,
gets-
but
yeah, we
you
can go
get a good sense.
into
of what's going on.
details.
okay.
So
So
I'm surprised about how much of it is just to make it nicer to work with in the end. It's a lot of work just on that side. Huh?
Oh, mathematics.
Ali says, I have some questions regarding serialization, but we can talk about that tomorrow.
well, we still have some minutes if he wants to expose those.
Do you want to expose those?
Through the chat or
I mean, you have a chat right there.
if he wants to, he can also talk. Or as you prefer, we can also do it tomorrow. It's just that, okay.
Okay. Well, speak tomorrow then.
Speak tomorrow.
Bye, everyone.
Bye,
Thanks for
everyone.
watching.
Ciao, ciao.
We love you.
We love you, Ari.